Hi everyone. Today we're going to be looking at conditional probability. You will need some paper and a pencil, your calculator, and you will probably want to pause the video occasionally to take notes. Okay, so let's go. Alright, so we'll start out with a brief review. So we have a contingency table based on restaurants, fast food restaurants in our area, and how often they had orders that were accurate and not accurate. You'll notice that we left off Chick-fil-A because they're most always right. Okay, so again, if your contingency table doesn't have totals, the first thing that you'll want to do is total up your rows, total up your columns, get everything total. All right, which brings us up to a brief review. Because we can ask all kinds of things with a contingency table, not just conditional probability. We can do basic probability. What's the probability that we had an order that is accurate? So, of the, oh my pen's crazy, of my 1,300 orders, that's so funny, 1,140 of them were accurate, which gives us 0.877. That's sort of a fun looking pen, but I think I'm going to change to a solid color. Okay, addition rule, and we did this current week. The probability of McDonald's or Taco Bell. And we talked about whether things were independent or dependent, or if they had an overlap. So McDonald's, we have 350 out of 1,300, and then Taco Bell we have 250 out of 1,300, which gives us 600 out of 1,300, and then with three significant digits, 0.462. Okay, so those are disjoint. There is no overlap. But the next one, Taco Bell or accurate, we do have an overlap. So we start out with Taco Bell. We have 250 orders from Taco Bell. We have 1,140 orders that are accurate. And of those 1,140 orders, 200 of the accurate orders were from Taco Bell. So that's 1,190 over 1,300, and you can change that to a decimal. 0.915. Okay, so far everything that we have done is just a quick review of how to use a table. Okay, and this is also a brief review. Multiplication rule. What's the probability that we have two accurate orders? If it says two orders, you wouldn't like get your order, give it back to McDonald's, and then get it back again. It would be one order and then another order. So typically things are without replacement unless the problem says otherwise. So two accurate orders. So we look at that and say, okay, 1,140 were accurate out of all 1,300. And then we take one out. We only have 1,299 total orders, and of those we'll have 1,139 that are accurate. So we'll get 0.769. Okay, two correct orders from McDonald's. Okay, so you just look at the orders from McDonald's that are correct, and it would just be just this little part up here. So we have 320 out of 1,300, a second order, so we'll have 1,299 orders, 319 of them are from McDonald's, and that will give us 0.060. Okay, so all of that was a brief review. Now we're going to look at conditional probability for the very first time. Conditional probability is defined to be the probability of an event given that another event has occurred. Okay, given that is the most important word in this whole problem. If it says something, it is given or given that, then you know that it's going to change. And what changes if it says given that? Whatever's given becomes your new denominator. So the first one, what's the probability of getting an order from Burger King? Doesn't it always happen that when you're right in the middle of doing something that your phone rings and they are telling you that the warranty on your car may have expired but that they can fix it? Go figure. Okay, which brings us to conditional probability. Conditional probability was probability of an event given that the other event has occurred. So Burger King given not accurate. We're only interested in the orders that are not accurate. So there are 160 orders that are not accurate. Of those 160, 55 were from Burger King, which gives you a probability of 0.344. That says a lot. Out of all the wrong orders that we did, 34% of them were at Burger King. Wendy's given accurate. So we have more accurate orders, 1,140. Of those, 175 are from Wendy's. So that gives us 0.154. Okay, accurate given Wendy's. Okay, and you'll notice that these are not the same. Wendy's given accurate, accurate given Wendy's. They're not the same. We're not going to get the same answer. So at this point, given Wendy's. Wendy's is what goes on the bottom. Whatever is given goes on the bottom. So we have 200 orders from Wendy's. Of those, 175 are accurate, which gives us 0.875. Okay. Accurate given Taco Bell. Whatever is given goes on the bottom. So we only have 250 orders from Taco Bell. Of those 250 orders, 200 of them were accurate, which gives us 0.800. And the last one, McDonald's given not accurate. So we're only interested in the 160 orders that are not accurate. Of those 160, 30 of them were from McDonald's, which gives us 0.188. Okay, so that is everything you ever wanted to know about conditional probability. And just in case, you can always extend your car's warranty. Have a good day. Did I delete that?